Okay, let us start from where we have finished the previous session. Just a moment. So, yeah. So what we have seen that if Jz is acting on this following eigenkette, so it is giving the result as eigenvalue h bar into beta plus minus 1. What about when j square is acting on this? So we have to compute that. So let us compute how if j square is acting on this eigenkette. What is it? Because j square and j plus minus already we have seen they commute with each other. That means I can write it in this format. And the leverage we can take it out. I mean from the notion j square acting on the eigenkette is h bar square alpha. So h uh, uh, j square on this thing will be h bar square alpha. We can write it in this format j plus minus alpha beta. So exactly I can see this j plus minus acting on alpha beta eigenkette does not affect the first element alpha, but rather it raises or lowers the second quantum number beta. So that is the takeout. We can get it j plus minus acts on alpha beta, raises or lowers the second quantum number beta by 1 unit. And if you remember, this is very much similar to the raising and lowering operator that we can annihilation operator or creation operator. So you can write it in this format that j plus minus acting on alpha beta is proportional to alpha beta alpha comma beta plus minus 1, or I can write it down some constant and alpha beta plus minus 1. Basically, this object c plus minus this is a constant. So you can think that this j plus minus when acts on this, it takes it to alpha beta plus minus 1. Either it raises or lowers the beta quantum number, and this is the proportionality. We will determine that later. So we are not I mean, immediately addressing that question. There are many other things we have to address it before. The trivia is just like creation, just like creation or and annihilation operator. So J plus cannot make this eigenkette infinite. Suppose I act on this, so it should be some constant which I have denoted c plus minus c plus in this case alpha beta plus 1. Now suppose I act again on this, it will be again some constant alpha beta plus 2. So it can go on like this. It can go on like this is 2. It can go on like this. But how many steps we can go? Is it infinitely many steps? No. We have to stop at some point and we will argue why we will do that. So we are in page 3. We will go to page 4 and discuss all this trouble if I infinitely cannot make j increase. So there exists an upper limit upper limit for the quantum number beta for a fixed alpha. Suppose I have choose alpha. Now for that choose alpha, I cannot make beta increase further. How to see this? How can I understand this thing? How to see this? Immediately it is not obvious statement. So Try to understand that j square minus jz square is positive. Everybody will understand that why? Because j square is nothing but jx square plus jy square plus jz square. So you can take any one square from the right hand side and you take it outside, and the rest of the things will be two squares, and two squares are always positive. So if I sandwich it in between uh, this eigenkate, basically I am taking the expectation value. So what is the number I will get? H bar square alpha minus beta square, because jz square will act on beta. It will be h bar beta, and again jz will act on that. It will be h bar beta, so h bar square, and j square act on this. It will be h bar square alpha. This is from the beginning what we have done. And again from delta alpha alpha delta beta beta, that will be 1, and this should be greater than or equal to 0, which implies that alpha has a lower bound, that is beta square. Alpha is minimum beta square, or it should be more than beta square. Since beta has an upper limit, and let's say I call it beta max, then there exists a eigenkate alpha beta max which can't be raised. What is the meaning of that? If we act j plus on alpha beta max, that should give you 0. Similarly, it should be a lower no, I mean maximum number for beta, beta max minimum number for beta, where the raising operator or lowering operator, if I act on that, it should produce 0. The same logic we have, which we have introduced earlier. So now j minus and j plus, we act on each other. So j square minus j raised square minus h bar is z. So if I act j minus j plus on alpha beta max, so basically it will be acting on this and nothing else. J square minus zz square minus h bar zz alpha beta max. So first term would be what? H bar square alpha. Second term will be h bar square uh, beta square max, and the third one will be h bar is there. H bar will come h bar square beta max, and the kate is as usual there. So this will produce, let me take h bar square outside, alpha minus beta max square minus beta max acting on alpha. Yeah, so this is the result. Now zz, I mean jz and j square, jz and j square, they commute with each other. So this j plus minus acting on this must be an eigenkate of j square. So let us write it down. But j z and j square commute. So j plus minus alpha beta must be a eigenkate of j square. Correct? Now, what is this? So let us agree j square acting on j plus minus alpha beta, which is nothing but j plus minus j square on alpha beta, and j square acting on this is nothing but let us calculate. Wait, just a moment. So I think instead of j square, I will calculate z uh, zz. Okay, let me erase this portion. Let me erase this portion and write it down in this format. Uh, let me erase this portion. Let me erase this portion and write it down in the result in this format. Z square, J square, sorry. Uh-huh. Just a minute. Let me choose the correct. Ah, ah, sorry. I think where is the pen one? Okay. Here's this portion. Yeah, it's coming over here. Sorry, it's the brush I used. Yeah. Okay, good. So Z square acting J plus minus on the eigengate. This will produce alpha H J plus minus alpha beta. Now you see, we have seen up to this point. Now what we want to calculate alpha. Let me go to the next page, it will be much easier. That will be page number, just a moment. Why this thing is coming? Sorry. This is page 4. I'm going to page 5. I cannot see. Just a moment. This logistics, sometimes it happens, but I don't want this left hand side bar. It is little bit handicapping me. Okay, let me stop it over here. I will just, I mean, I'm not happy with this logistics. So let me finish, figure it this thing, then I will get back to you again. Let me stop the recording over here.